What's up, everyone? Today I'm going to talk about the evolution of the mobile standards of the physical layer. So I will start with FDMA and end with OFDMA. These are the standards. These are the multiple access protocols that have been used in different kind of generations of mobile communication technologies like 2G, 3G, and 4G. So I'll first start with FDMA. So FDMA, it stands for frequency division multiple access. So let us first consider a system that is sending signals, that is transmitting. So I'm going to draw them as the Gaussian pulse shapes. So let's draw it like this way. So these symbols, as you can see, these symbols, they represent some bits, maybe positive or negative if binary. They are being sent in the time domain as ones or zeros, or we can say as ones or minus ones. So we need to multiply this with a carrier which is at the frequency of the transmission of our antennas. So let's multiply this with the carrier frequency. So this multiplication, what it does in the frequency domain, if we conduct Fourier transformation, it can be seen. I will show you right now. So the Fourier transformation of Gaussian shape is Gaussian. So this goes as follows. So this is our carrier frequency F1, and this will be like this, F1 and minus F1 in the frequency domain. So it will occupy bandwidth around the carrier frequency. So what if we have a collection of users? Let's have a look at that too. Let's say we have two users. They're sending all the time at the data rate in the set here, like T, 2T. In this case, we have another waveform in a different carrier frequency. So let's say that we have this. Let's draw this again. So T, 2T. So I'm going to use the bracket to indicate that we have multiple users. And this, let's do the multiplication of the carrier frequency. This one, this F1 is for user 1, and this one, let's say for example this one is for user 2. So and if we conduct the Fourier transformation, and what we can see in the frequency domain is as follows. So the first of all, the user 1 will be there. This is, let's say, F1, and this will be minus F1. And let's use a different color for user 2. So this one, let's say, is for user 2, and this one, let's say, is for user 2 too. So in this case, we need the guard bands. Let's use a different color for that. Let's use red. So we need the guard bands for this. So this is kind of like FDMA, a very like short view of that in the physical layer. And now the next thing that I'm going to cover is TDMA. So let's get into TDMA. So I have to get rid of this. I think that's enough. So the next thing that I'm going to do is TDMA. Oh, that's red, right? I need black. So in TDMA, we're not transmitting at the same time. Rather, we divide up time and allocate time among different users. We transmit at a higher symbol rate than FDMA. One user sends quickly at a shorter period of time before another user can send. We'll use black color for user 1 and green for user 2. Let's see a diagram for two users in time domains separated in time slots for TDMA. So this is, and then I need a different color. As I said, I'll use green. So this one is user 1, and this one is 2, this one is 1, and this one is 2 again, and it goes on. So in this case, like as I said, that in frequency division multiple access, we need cut bands in frequency domain, but for TDMA, we need guard bands also. So, but in this case, we need guard bands in the time domain. So now this gets multiplied by the same carrier frequency that I have used in FDMA. So this gets multiplied by the same frequency as FDMA, the carrier frequency, like this. And since we are sending quickly, we use more frequency band, and in that case our frequency domain shapes, I mean the frequency domain is going to look different, way more different than what I've seen in FDMA. So it will look like this. So it will occupy more band, as I said. It will look like this. Let's say this is F1 and this is minus F1. So altogether, this is GSM, like TDMA plus FDMA. This is used in 2G. And our next target is that we're going to describe in short CDMA. Basically, wideband CDMA was used in 3G, so I'm not going to cover exactly wideband CDMA, but let's have just, I mean, a very normal and general look of the physical layer of the CDMA. First, I need to get rid of this. In CDMA, actually, we can draw the symbols like frequency division multiple access. So let's draw it. So like this way. So I'm going to use the bracket. I'm going to use the bracket for what? I'm going to use the bracket for indicating lots of different versions of these symbols for different users. Each user send at this kind of rate, like T to T. In CDMA, we're going to multiply each of these users by a digital code. Codes made of chips, and this code rate is much higher than the symbol rate. We have kind of like different code for different users. Digital codes are orthogonal to each other. Then all of these get multiplied by the same carrier. So let's have a look at this. So we have got codes like this. Let's say for this one, I'm going to use a different color for this. Let's say we have two users, so I'm going to use blue for user 1. And then I'm going to use yellow for user 2. So these are the codes, and all of these, they get multiplied by the carrier. So in the frequency domain now, we have a same system as we did for TDMA. It is because the chips, these chips are like a very high rate symbols like we have used in TDMA. So our frequency domain is going to be similar too. So it's just going to be like this, as we have seen earlier. That is F1, and this is minus F1. One of the biggest challenges for this CDMA is that chips, they have to be orthogonal, which is very difficult to maintain. It's a very big challenge. So in practice, they're not absolutely orthogonal. And the next thing that I'm going to cover is OFDMA in a very short way. So let's do that. First, I need to get rid of this again. So let's talk about OFDMA in short. OFDMA. So OFDMA takes the symbols and put them into vectors like this: x1, x2, x3, and these vectors x1, x2, these are just complex numbers. We need to put them in inverse Fourier transformation. So if we just do inverse Fourier transformation, and then it gives the time domain signal, which has all the characteristics of frequencies that are from the data. So this will give us like this. So I'll use bracket to indicate multiple users. This is for multiple users, and as I said just now, in the frequency domain, what I have to do is we select some of these x's like x1 and x2 to be 0. That's how the other users can send signals. I mean, like the subcarriers where other users can send signals. So this results in sync pulses. They overlap. The other users also overlap in the neighboring pulses too. So reason we can do this without the guard bands is because we have improved carrier synchronization algorithms among different users. So it's going to look like this in the frequency domain. So let's use different colors for 2 users. So let's use blue for user 1. So as I said, it will look like sync pulses. Oops, sorry. And then so this is for user 1 and this is for user 1, and then change our color for user 2. So these are already overlapping, and we will have neighboring pulses too that will overlap with each other. So in this case, like one of the biggest benefit is that we don't need the guard band at all. and we are not using all the frequency at the same time, and we're getting rid of to some extent the Gaussian pulse steps too. So this is kind of all for this tutorial. I have just covered a very basic view of the physical layer of different mobile standards. For your understanding, so this OFDMA, this one was a part of 3G, and later on this one turned into LTE, and we started calling it as 4G. And then wideband, the WCDMA, wideband CDMA was the actual 3G, and TDMA, FDMA, what we have seen, TDMA plus FDMA, they were used in 2G, their GSM. So, in many cases, you have heard these terms and you exactly didn't know like which one is the part of which standard. And this is, I think, a very simple video to understand them. You don't need much of the background to understand these things. So there are lots of tutorials and lots of videos in the internet that where you can find detailed view of these things, but there are not many which can discuss in a very simple way to give you some intuition. I think this video will help you for that. Thank you.